안녕하십니까. 인천대학교 모바일 컴퓨팅 연구실의 전원호입니다. 지금부터 무구속 무자각 상태에서 수면 패턴 모니터링을 발표하겠습니다. 앞에 보이는 이 그림은 수면 패턴 모니터링 시스템을 구성한 가상 환경을 보여주는데요. 무구속 무자각 상태에서 사용자의 수면 패턴을 구분하기 위해 7개의 센서를 사용하였습니다. 천정에는 비접촉 온도 센서, 적외선 카메라, 조도 센서를 설치하였고요. 침대 측면에는 수면의 질을 영향에 줄 수 있는 이산화탄소 센서, 미세먼지 센서, 소리 감지 센서와 마이크를 설치하였습니다. 사용자는 압력 센서가 내장된 스마트 베개를 메고 침대에 눕게 되는데요. 각 센서는 1초 간격으로 데이터를 수집하여 데이터베이스에 저장하게 됩니다. 압력 센서가 내장된 스마트 베개는 사용자의 누운 자세를 판별하고 수면 자세별로 지속 시간을 파악합니다. 또한 스마트 베개는 총 수면 시간과 시간대별 뒤척임 횟수 등을 분석해 수면 상태의 질을 파악하기 위해 사용될 것입니다. 스마트 베개를 사용한 수면 자세 판정 정확도를 검증하기 위해 적외선 카메라가 캡처한 수면 자세 이미지와 비교할 것입니다. 소리 감지 센서를 사용하여 기준 데시벨인 60데시벨 이상의 코골이, 이갈이, 주변 소음 등의 소음 발생 시에 약 15초 동안 녹음하도록 하였습니다. 수면을 방해하는 요인이 발생했을 때 수면 상태의 변화를 알 수 있을 뿐만 아니라 사용자의 건강 상태도 확인할 수 있습니다. 스마트 베개, 체온과 소리 데이터는 사용자로부터 획득할 수 있는 직접적인 수면 정보이고, 반면에 주변 온도, 습도, 이산화탄소, 미세먼지와 같은 주변 환경 데이터는 수면의 질에 간접적인 영향을 미치기 때문에 본 연구에서는 이들 데이터는 수면 패턴 분석 과정에서 보조적인 역할로 사용될 것입니다. 주변 환경 데이터는 에어컨 컨디셔닝 조절을 위한 제어에 충분히 활용할 수 있습니다. 스마트 베개와 주변 환경 데이터만을 사용해 분석한 수면 패턴과 사용자의 생체 정보와 비교를 위해 팔목 부착형 맥박 센서를 사용했습니다. 또한 추후의 응용 목적으로 심리적인 안정과 숙면 조절을 위한 응원 장치를 추가로 설치하였습니다. 앞에 보이는 이 그림은 7개의 개별 센서가 있는 비착용형 센서 기반의 수면 패턴 모니터링 시스템의 전체 시스템 구성도입니다. 앞에 보이는 이 표는 모니터링 시스템에 사용된 센서들의 기능과 장세의 스펙을 요약한 것입니다. 다음은 사용자의 수면 데이터를 수집하는 센서입니다. 먼저 스마트 베개입니다. 스마트 베개는 수면 자세를 판별하기 위해 압력 센서 8개를 일직선으로 수평 배치하여 구현하였습니다. FS406 센서는 센서 위에 압력, 무게, 터치 등의 힘이나 압력을 감지하는 센서입니다. 사각형 모양이고 비교적 넓은 범위의 압력을 측정할 수 있습니다. 머리의 가로 길이는 양쪽 귀 위쪽의 수평거리입니다. 한국인의 경우 머리의 가로 길이는 남자는 16.8cm, 여자는 15.9cm입니다. 스마트 베개는 앞에 보이는 그림처럼 압력이 발생한 지점을 기준으로 3가지 수면 자세, 정자세, 좌우 옆으로 누운 자세를 판별할 수 있습니다. 스마트 베개에서 측정 가능한 정보는 수면 시간, 수면 자세와 뒤척임 정도입니다. 1초 간격으로 수집된 압력 데이터를 기계학습 알고리즘인 서포트 벡터 모신을 적용하여 수면 자세를 판별하였습니다. 약 1년 동안 스마트 베개에서 수집한 약 100만 건의 압력 샘플을 데이터셋으로 사용했습니다. 적외선 카메라는 사용자의 수면 자세와 수면 상태에서 뒤적인 판별 결과를 검증하기 위한 목적으로 설치하였습니다. 불빛이 없는 수면 환경에서도 촬영이 가능하도록 적외선 카메라 모듈을 사용하였습니다. 수면 중에 적외선 카메라는 우측에 있는 B의 그림에 보인 것처럼 스마트 베개의 샘플링 간격과 동일하게 1초 단위로 수면 자세 이미지를 캡처합니다. 비접촉 온도 센서는 천정에 설치하였는데요. 사용자의 체온을 측정합니다. 비접촉 온도 센서는 최대 1m까지 측정이 가능합니다. 체온 측정은 주변 온도와 습도 측정이 동시에 이루어집니다. 수면 중에 사용자가 내는 소리, 코골이, 이갈이 등 주변 소음 발생 시에는 소리를 감지하고 녹음할 수 있도록 하드웨어를 구현하였습니다. 소리 감지에서 검출한 노이즈가 60dB를 초과하면 라즈베리 파이 보드에 연결된 사운드 카드를 작동시켜서 사운드 카드에 연결된 마이크를 통해 소리를 녹음합니다. 기준 데시벨이 초과한 소리는 최대 15초 동안 녹음합니다. 소리 감지 센서는 앞에 보이는 그림에 보인 것처럼 마이크의 소리 신호를 감지하고 이를 증폭해 아날로그 신호로 변환하는 센서입니다. 소리 신호를 증폭할수록 소리 감지 감도는 증가하게 되는데요. 소리 감지 센서의 가변 저항을 조절해서 소리 감지 조절을 할 수 있습니다. 다음은 환경 데이터 수집용 센서입니다. 먼저 비접촉 주변 온도 및 습도 센서입니다. 주변 환경 온도가 지나치게 높거나 낮으면 건강한 사람도 수면의 양과 질에 문제가 생길 수 있기 때문에 수면을 위한 주변 환경 온도는 수면을 조절하는 데 중요한 인자로 볼 수 있습니다. 환경 온도의 변화는 수면의 지속성에 영향을 줄 뿐만 아니라 서파 수면, 렘 수면에도 영향을 줍니다. 수면 중에 주변 환경의 온도와 습도를 측정하기 위해 비접촉 온도 센서와 온습도 센서를 설치하였습니다. 도도 센서입니다. 사람의 눈은 빛을 감지하면 뇌에서 코르티솔이라는 호르몬을 분비합니다. 코르티솔은 사람의 몸을 각성시키고 수면 상태에 영향을 줍니다. 반대로 어두워지면 수면을 유도하는 멜라토닌 호르몬을 분비하게 되는데요. 이런 호르몬의 기능을 제대로 작동시키고 편안한 수면 상태를 만들려면 잘 때 조도를 어둡게 유지해야 합니다. 조도 센서에 사용되는 감각 센서는 주변의 밝기를 측정하는 센서입니다. 광 에너지인 빛을 받으면 전자가 발생하여 전도율이 변하는 광전 효과를 가진 센서인데요. 조도 센서는 전도율이 밝기에 비례하여 선형적으로 증가하는 것이 아니기 때문에 정확한 룩스 값을 구하기보다는 밝고 어두운 정도로만 판별하기에 적합합니다. 이산화탄소 센서입니다. 수면은 온도, 습도, 소음, 조도, 공기, 질 등의 다양한 환경 요소에 영향을 받기 때문에 수면 환경의 조성은 중요합니다. 특히 수면 시간 중에 이산화탄소 농도가 높아지면 환기를 할 필요가 있습니다. 실내 이산화탄소는 사람의 호흡에 의해 주로 배출되거나 난방, 취사할 때 배출되는데요. 실내 최적, 실내 인원, 난방 여부와 환기 장치 등의 영향을 받기 때문에 실내 오염의 주요 지표로 사용됩니다. 한국생활환경학회 연구 결과에 의하면 이산화탄소 농도는 깊은 수면을 방해하고 얕은 수면을 취한다고 합니다. 즉 이산화탄소 농도가 높으면 얕은 수면 상태인 렘 수면의 빈도가 훨씬 높아집니다. 이산화탄소 농도가 700에서 1000ppm이면 불쾌감을 느끼게 되고 1000ppm에서 2000ppm일 경우에는 피로와 졸림 현상이 나타나는 등의 컨디션 변화가 일어납니다. 이산화탄소 농도가 2000ppm 이상이면 두통과 어깨 걸림을 느끼게 되고 3000ppm을 초과하는 경우에는 현기증을 일으키는 등의 건강을 해치게 됩니다. 미국, 일본, 중국과 한국에서는 실내 환경의 이산화탄소 농도를 1000ppm 이하로 유지할 것을 권고하고 있습니다. 앞에 보이는 그림과 같이 이산화탄소 농도 측정 장치를 침대 왼쪽에 설치하였고 이산화탄소 농도에 따라 4가지 상태로 구분하였습니다. 이산화탄소 농도가 나쁜 상태이면 앞에 보이는 그림에서 보인 것처럼 적색 LED가 점등이 되고 스피커를 통한 멜로디 알림 기능을 구현하였습니다. 다음은 맥박수를 측정하는 웨어러블 센서입니다. 맥박수는 자율신경에 의해 조절되고 수면상에 따라 변동하는 것으로 알려져 있습니다. 깊은 수면에서 맥박이 느려지고 변동이 적은 반면에 얕은 수면에서는 맥박이 빨라집니다. 특히 안구가 심하게 움직이는 렘 수면일 때 맥박이 높아져서 변동도 커집니다. 본 논문에서 제안한 무구속 무자각 방식 수면 패턴 분석 결과를 사용자의 생체 정보와 비교하기 위해서 앞에 보이는 그림과 같이 팔목에 착용하는 맥박 센서를 사용하였습니다. 맥박 측정 장치는 과학 기술을 기반으로 혈액의 움직임을 측정하여 맥박수를 체크합니다. 본 논문에서는 수면 베개를 이용하여 수면 자세, 정자세, 좌우 옆으로 누운 자세를 측정하기 위해서 이 메모리 폼 베개에 8개의 FSR 406 압력 센서와 아두이노 나노를 내장한 베개를 제작하고 수면 자세를 판단하기 위해 어플리케이션을 구현하였습니다. 무구속 무자각 상태의 수면 중에 수면 자세와 뒤척임 상태 등의 수면 상황을 기록하고 분석하여 수면자의 수면 패턴을 확인하였고 환경의 문제점을 파악할 수 있도록 수면 중에 수면 상태의 주변 환경의 온도, 습도, 소리, 수면자의 비접촉 신체 온도 등의 센싱 값을 측정하여 실시간으로 데이터베이스에 저장하기 위한 플랫폼을 구축하였습니다. 사용자에게 수면 패턴과 수면 환경 정보를 제공하여 수면과 깊은 잠을 방해하는 요인들을 확인하고 개선할 수 있을 것으로 기대됩니다. 기능성 수면 베개, 수면의 질을 높여주는 수면 베개, 자세 교정에 도움이 되는 수면 베개를 사용하면 보다 좋은 수면의 질을 높일 수 있을 것입니다. 이상으로 무구속 무자각 상태에서 수면 패턴 모니터링 상태를 마치겠습니다. 감사합니다.
Thank you, Unho-jion, for your nice presentation. I'd like to audience if they have any questions. I think they do not have any questions. Now thank you, Unho-jion. We'd like to move on to next talk, which is website platform construction for public big data. So for this talk, I'll be presenting. Could you please close your screen? Thank you. The second talk is website platform construction status for public big data. Hello everyone, my name is Sovit Bhandari. I'm here for the presentation for the topic website platform construction status for public big data. The contents of my presentation includes introduction and motivation, quality metrics of big data, DCR check framework, results, dashboard, and conclusion and future work. Now let's move on to introduction and motivation. In recent years, government in many countries have recognized the importance of big data in boosting their economies. So they are implementing the philosophy of open data, open government data to make public data easily and freely available to everyone. The good quality data can boost a country's economy, while a poor quality can jeopardize its efficient use and reuse. Most open government data portals don't have a feature of checking the quality stored in their platform, and moreover, they do not provide the real-time service. To address this problem, to some context, we have proposed a framework that can automatically assess the quality of data in the form of data completeness ratio and visualize it in real time. The framework is validated using the data of South Korea. The 6 characteristics defined by the International Data Management Association to ensure data quality are completeness, accuracy, consistency, validity, uniqueness, timeliness. But in this paper, we'll only talk about how can we quantify the quality of the data in terms of completeness. This is our general data completeness ratio check framework. At first, the data is the API of the data is stored in an API collection, and after the data is downloaded, it is processed using the Python programming, and the processed data is sent to the website framework for visualization, and the website is deployed for the visualization of the calculated data. And this is a Django-based DCR check framework. In this framework, we first assess the open source data platform. For this, we are using the open source data platform of South Korea, and we collect the API of the data available in that platform in a API database. And the API database is called using Python program to download the data. And after downloading data, the data analysis process is done. And once the data analysis process is completed, the data is stored in the backend of the Django framework. From the backend, the views.py module calls the data from the backend of the Django framework and renders in the front end using the scripting language like HTML and programming language like JavaScript and CSS for styling the scripting language. And once the website is made to visualize the DCR of the file-wise DCR of the South Korea, Apache deployment web server is used to deploy the website to the internet, and we use the browser to access the website. These are the steps we already talked about. In the Open Government Data Portal of South Korea, we have 93 functional APIs, and the API can be found in the metadata section. The API database is made like this. We have the name, and that is followed by the API. In the third step, we use the Python programming language to download the data automatically. In the fourth step, we process the data. We calculate the data completeness ratio region-wise using the Python programming language. In the fifth stage, Django-based framework is used for visualization. And Django is a Python-based web framework that follows model template use MBT architecture pattern, which is shown in the figure. In the fifth stage, the calculated data is shown in the front-end template using the Django built-in multivariate template, as shown in the figure. In sixth step, Apache web server is used to broadcast the website, which is a free and open source web server, and it provides web content through the internet. And finally, we access the website, and the domain name for our website is cityview.inu.ac.korea. And these are the some few results of our calculated DCR, and we have only selected some regions of calculated results, which includes National, Incheon, Seoul, and Gyeonggi. And we calculated for the overall and the mandatory data fields. This is the radar chart, which shows the calculated DCR. We can see in the chart that some of the data files have a good DCR, while some are not good. This is our actual dashboard, and which can be accessed through the URL cityview.inu.ac.korea. And once you click in the Open Government Data option in the dashboard, you can see the DCR calculated, file-wise DCR calculated, which is provided on the basis of different regions, including the national one. And this is the data quality statistics, which shows the real-time statistics of our calculated DCR. Along with the calculated DCR, it shows the volume of the data, data type, and so on. And conclusion and future work. In this paper, a general framework is proposed to automatically check and visualize the quality of data provided in OGDB with respect to DCR in real time. To validate the framework, we downloaded the 93 standard tabular data from the Open Government Data portal of South Korea. The quality of data is quantified in the basis of data completeness ratio, considering the overall and mandatory data fields. The average DCR value of South Korea for the national was not even 95% when the mandatory fields were considered, and the result was even worse when there were non-mandatory fields, because most of the non-mandatory fields were empty. In our future work, we'll consider other metrics besides DCR, like accuracy, timeliness, consistency, to calculate the data quality. And the framework will consider the OGD from different countries, not only for one country. These are the references that I have used for my study. Thank you. Any questions? This is it. Now, let's move on to the next talk, which will be given by the principal engineer Navin Ranjan. The topic of his presentation is service ideas of public standard data, and which is from the context.
Excuse me, can you hear me? Session chairman, I'm Kim.
Thank you, Professor Kim.
For a while. Can you hear me?
Yes, Professor.
Yeah. Right before the moving into the next speaker, I'd like to ask all the members to attend the taking photo time. Okay. Before moving into the next speaker, we are going to have time for the photos for this event. Okay.
Okay. Thank you, Professor.
Okay. Thank you for your understanding.
Lei Ping, I would like to open your camera.
Okay. Thank you. Hello. Okay. So sorry for interrupting again. And we are having this conference as a hybrid form. So online attendees and offline attendees can have time to share this ceremony all together for a while. Okay, thank you. And would you move forward from the flowers?
좀 올려야 되지 않을까요? 저 뒤에 파란 카드가 있는데.
일단 이 사진들이 있어야 되니까
네.
아니면 다른 포스터가 있나? 진행자한테 부탁을 하고 원래 좀 찍고. 아니. 아, 죄송합니다. 뒤도 나와요. 그 심포지엄에
조금만 이쪽으로 와주시겠어요? 네, 중앙에 안 맞아요.
굉장히 뭐 책 이런 거 없어요? 특별나 뭐 이런 거는?
있어. 잠시만.
네, 이런 네, 상황들을 좀 이렇게 생각해서 이렇게 세팅을
할게요.
바르는데.
하나, 둘, 셋.
자, 화이팅 한번 하시고.
네.
볼까요?
이 현수막까지 나오는 거예요.
하나,
하나, 둘, 셋.
이걸 올리기 현수막이 보이면
잠깐
올릴 수가 있나?
이것도 한번 찍고.
네, 여러 장 찍으면 없고요.
네. 자, 뛰시죠.
하나, 둘, 셋.
여러 개 눌렀어요.
네,
이거
감사합니다.
올릴까요?
네, 잠시만요. 어떻게 올리지?
아니 이거 책자를 여기다 이거를 뭐 그래서 이걸 보여드릴게요.
혹시 이거 보고 스크린 어떻게 올리는지 좀 도와주실 수 있나요?
일단 이 정도 하고 하면 안 될까요? 뭐 여기 꼭 여러분들이 여기 볼 수 있어요?
네?
네,
네, 보여요.
아. 네.
그냥 하실 건가요?
네, 그냥 진행하시면 될 것 같아요.
We finish the first time. We continue to present.
I'd like to ask next speaker to start his presentation on the topic service ideas of public standard data from the contest. You may begin.
Thank you, Sovit Bhandari, and greetings to all the attendees. I'm Naveen Ranjan, and today I'm here to present on topic service ideas for public data standard from the contest. So the content of my talk is first I'll briefly discuss on the introduction what I'm going to talk about, and the most of the part of this talk will focus around the service ideas for the implementation of public standard data. I'll speak on multiple topics and I'll provide some brief discussion on that. And the final part of this talk is conclusion, and I'll highlight some of the future work we are going to do for this. So as an introduction, first we're gonna understand what public standard data means. It is an idea that the data should be easily and freely available to use and republished by anyone without any restriction to copyright or patent or any kind of control. And also, as it says that standard data, it should follow a specific set of rules to ensure the quality. So the areas where this open data is going to create new values are on transparency of a government work, democratic control, participation of any individual, empowerment, innovation, and improvement of efficiency and effectiveness of already available government services. These are some of the areas. And usually this kind of data, public data, are too long to handle. It's in terms of volume, or it is too complex to manage or to extract the meaningful information by just seeing at this. And it doesn't tell a story at all, and it doesn't drive any decision from the original source. So to have a story of what kind of, to have any kind of service based on that data, we can use multitude of method. Like we can just visualize based on location, or like if it usually data are in table form, but if we use that as a visualization, this is just an example, we can particularly understand what is the story of the data. So for this, because of this, we in this section we're gonna talk on some of the service idea from that public data. In this, there is two parts I'm going to discuss. One is what we have already implemented, and we can see that implemented idea on website ctview.inu.ac.kr. Among that, I'm going to talk about the 4 visualization. And the other part is the plant service, which is an idea from the contest which was held recently. And it is divided into 3 sections. One is empirical content research, which have 7 ideas. And from the contest, we have selected 9 excellent ideas, and the other ideas that is not as excellent, but not also worse. We have 27 of them. So for the first part, that is implemented service idea, some of the attribute that is used in this attribute of that implemented service is all the data are GPS, all the data contains GPS location, that is latitude, longitude of the information, which was easier for us to visualize by map, and also it is easier for the end user to understand what kind of data was there. In addition to that, we have also designed a system based on location and search radius. So you can just put some location name and some search radius around that point. And also the data are categorized. We will see in next slide. So one of the 4 implemented service is protection zone for elderly and disabled. So when we try to find the protection zone for elderly and disabled nationwide, we have a method like we can just input the area where we are going to search and the search radius around that area. So this is an example which is taken from our website. Now, in this example, the search area is directly placed at Incheon, and the search radius was 10 kilometers. And these are the location. These are red star are the location where these protection zone are. So it's very easier for anyone to view what are the protection region nearby them. The other implemented service areas was national performance event information. This is the data visualization, which is divided into 12 parts based on the monthly data. This can give us in which month where was that national event held. And in addition to that, we have another attribute which can just say which among these locations where there was parking service available and where there was no parking service. Is very useful for the end user. The third is national library information. These red star are the location of all the libraries inside Incheon. And when you hover over each of the location, you'll get the starting and ending, start and end working hour for holidays, normal days, and for weekend, and all the what kind of how many book materials and everything book materials were present in that location. Similarly, the fourth and the last one that I have used to visualize for implemented services is the National Auto Repair Company information. These all red star are the location inside the Incheon region, and similarly to previous, if we just hover over each location, you'll get all the information required very easily. Instead of searching on a CSV or table-based visualization on the map is very easier for end user. So hereafter, I'll talk about the topics on the service idea that was collected from the contest. And the first part is empirical contest research. So in this section, I think there is 7 selected topics. So I'll go one by one and highlight some of the point for that. For one, that was tourist perception through the user generated content. So the main goal is to analyze and visualize the tourism perception, which by checking on the online reviews given by the tourist at the particular destination. And the focused area for this kind of service idea is mainly for Incheon metropolitan city. For the second, it is artificial intelligence based automated vehicle classification. The goal is of this idea is to generate a machine learning model to classify automobiles and to display the real-time vehicles classification result. And the premises for this is for the university, that is for IONU, and the data source will be taken from the CCTV image. Similarly, for the third one is to study of a national library standard data utilization measures, which it suggests on the various ways to utilize and improve the usability of already existing national library throughout the country. The fourth one is crime rate analysis and the correlation between drowsiness shelter or a rest area versus traffic accident. It contains 2 parts. So we're gonna, for this area, is provide the efficient crime and accident prevention solution. By it analyze the change in for the first part, it analyzed the change in a crime occurrence statistics in the area where newly street light and smart light and CCTVs were installed. And the other part is the correlation between the traffic accident versus the drowsiness and rest area shelters. For the fifth topic, it is the development of evaluation algorithm through the analysis of descriptive question answer data. It can be done by analyzing the narrative self-introduction and motivation, reliability verification of the result through the supervised learning. And the goal is to develop an algorithm for predicting evaluation result for new unseen data. Sixth one is for traffic related city view data analysis. It is the study for the pedestrian safety. 7 is for analysis of CCTV blind spot. Based on the national CCTV data around the national CCTV standard data, we can analyze and generate a CCTV blind spot. For the next section, we have selected 9 of the excellent ideas from the contest. They are as at number 1, it's creating tourism industry support idea using national traditional market standard data. It will positively impact. It will have a positive impact of a traditional market and international tourism industry. Second is of a tourism course suggestion using mobile and web application service. It will suggest the best tour course in the city for foreign tourists. It's very helpful for them. And for number 3 is temporary parking allowed area notification. Also, the name is yes parking. It provides the parking status around the user based on their GPS location, and also give the information of illegal parking report service based on the user location to the organization who handle the parking illegal parking service. And the 4th one is location of for operating food truck. Will give the food truck name, like store name, and the food recommendation service. The objective of this service is to recommend full food truck location where it is best for them to operate. Give the route setting like easiest way from their current location to the recommended location, and it also helps to provide the menu recommendation for the tourist. 5th one is for mobile application for non-smoking areas. It is the idea is to develop an app based on the GPS location of the user. The system will just check whether location is provided area for the smoking or not, is it illegal or not, and display the location of a smoke-free area on the map. It will just suggest the area where it is not illegal for smoking. 6th is the information and warning services for prohibited parking area. It will provide the information on prohibited parking area through the map, real-time confirmation of prohibited parking area, and development of a warning services. 7 is CCTV location selection using QGIS. It is easier to visualize newly installed install location of CCTV on QGIS. It is improvement of home safely application using the standard public data. In this idea that they are trying to use the existing data such as National Women Safe Keeper House, National Women Safe Delivery Box, and National Safety Emergency Bill location to develop an app called Safe Home app to provide the service location to improve the accessibility and the safety. And the 3rd part of the contest is other areas. It means that it's not selected as excellent, but also has a potential for changing the service. So I'm just going to read out some of the selected one. So for the first, it's tour guide by providence and length using the National Road Tourism Standard Data. Analysis of a commercial district using big data. Complete information of tourist destination by region. Bicycle travel app. Activation of regional specialists nationwide. Reservation app for electric vehicles, charging station nationwide. For smooth parking. Comparison of number of dementia center according to the number of dementia patients nationwide. Some of them are EV charging completion time prediction and commercialization, evaluation of expected economic benefit and reduction of CO2 emission, National Library Information Standard Data proposal, easy communicate direction application, analysis of traffic accident factor using National Unmanned Traffic Enforcement Camera Standard, track down on the overload vehicles using speed camera and CCTV data, improving the welfare of driving using a drowsiness shelter using standard data, elementary school student traffic safety check, analysis of practical utility and traffic enforcement, suggested information plan for big data based relief for the prevention of crime related to women. So these were some of the selected topic, and for this section, I'm going to conclude and give some of the future works. In this talk, we have briefly discussed on the various standard data service ideas. We have seen that idea has potential for improving the existing services. And as a future work, we are planning to implement empirical content research and contest excellence categories. This will be the first part to go, and if we complete this work, then we'll shift to the other ideas that was presented from the contest. So this was the talk on the topic. Thank you.
Thank you, Navin Ranjan, for your nice talk. I'd like to ask audience if they have any questions. I think there is no question from the audience. Thank you, Navin Ranjan. Now you may close your presentation. For the last speaker, I'd like to ask Professor Lei Peng for his presentation. I think on behalf of Professor Lei Peng, his PhD student Ziao would be presenting. You may start your presentation.
Thank you, everyone. My name is Yu Jiao, coming from Shenzhen Institute of Advanced Technology, Chinese Academic of Sciences. It's a pity that Dr. Peng Li can't attend the academic conference. Due to a temporary emergency, I will complete the presentation on his behalf. The topic of my presentation is integrated prediction of regional traffic situation based on multitask spatial temporal network. I will make my presentation from the following 5 aspects: introduction, related work, methodology, experiment, and conclusion. The first is the introduction. Nowadays, traffic congestion and parking difficulties are very common in our daily life. As an important part of intelligent transportation, traffic prediction always plays an important role in alleviating traffic congestion and difficulty in parking. The vehicle's behavior includes driving and parking. Accordingly, traffic prediction should include the road traffic flow prediction and parking situation prediction. They all have an impact on the overall traffic. More importantly, we found that road traffic and parking situation are closely related, especially near some popular points of interest. On the one hand, the huge traffic flow puts pressure on the parking lots. For example, according to the Shenzhen Traffic Police Department, the traffic flow to the Eastern Scenic Area on the first day of Dragon Boat Festival in 2020 exceeded 6,000. And the parking lots were all saturated. On the other hand, limited parking spaces cause vehicles to cruise at low speed on the road. According to the survey, the invalid traffic flow caused by looking for parking lots or parking spaces accounts for 15% of urban road traffic. In addition, studies have shown that 30% traffic congestion is caused by vehicles looking for empty parking spaces. The above examples show that there is an inseparable connection between road traffic and parking behavior. At present, traffic prediction can be roughly divided in 2 categories, whether it's traffic flow prediction or parking occupancy prediction. One is the model based on single historical time series, which only consider the historical time data of the prediction package. The second is the prediction model based on the influence of multiple factors. The prediction model based on a single time series can be divided in 2 categories. In traditional statistical method, we take ARIMA as an example. The computational efficiency of the ARIMA model is high, but the anti-interference ability is poor. In the deep learning method, we take TGCN as an example. This model takes into account the spatial relationship between roads and has a better prediction effect than traditional statistical method. But the prediction model at the peak is less effective. In prediction models based on multi-factor influence, we take GCN LSTM as an example. This model takes into account the impact of weather and traffic speed on parking when predicting parking occupancy. The prediction effects is improved. In addition, many scholars also take into account the influence of large events, holidays, and weather when predicting traffic flow. However, these are only one-way effects. Their common shortcoming is that they, they ignore the interaction between road traffic and parking. And we have already mentioned road traffic and parking are closely related. If we predict them separately, we will not fully grasp the traffic characteristics. In order to make full use of the interaction between road traffic and parking, and then further improve the prediction accuracy, we proposed an integrated model for regional traffic situation. It's multiple input and multiple output model, and also a multitask model. Next, I will introduce how to build this integrated prediction model. First, we should represent the parking lot and the roads as two topologies. The road traffic situation is separately dependent, so the road network and parking lot network involved are very suitable to be represented by graph structure. In the road network, roads are regarded as nodes. If two roads intersect, the two nodes are connected, then the average traffic speed is taken as a node feature. In the parking lot network, parking lots are regarded as nodes. Connect two nodes if the shortest path between them is less than 600 meters. And node feature is the number of parking spaces occupied. Second, we propose a multiple channel spatial network to extract the spatial feature. One model is used to extract the spatial feature of the road network, and the other channel is used to extract that of the parking lot network, then fuse the spatial features of two channels. The main part of the model is two-layer graph concluder network, which has strong spatial feature extraction ability. The multi-channel spatial network is expressed as this formula. Finally, the output of multi-channel spatial network is taken as the input of gated recurrent unit to extract the time feature and complete the final extraction. The output of the gated recurrent unit is average traffic speed prediction results and parking occupancy prediction results. The whole multitask spatial network is taken as these formulas. The model construction is here. We define a loss function and then train the model to make the loss function as small as possible. The next is experiment. We select 49 parking lots and 23 main roads in Luohu district in Shenzhen as the experiment scenario, and observe the prediction results of Luohu hospital parking lots and the Nanhu roads. The two figures shows the real data and prediction results of Nanhu roads and Luohu hospital respectively. The blue line is the real data. Red line is the predict data based on our proposed model. And the green line is the predict data based on the model proposed by Yang et al. and we call it single task model in this paper. The prediction effects of the two models are basically acceptable. However, we found that there seems to be an obvious prediction decline for single task model during the period when the parking lot is highly occupied. To figure out why, we calculate the accuracy per time steps on the test set. Accuracy is calculated by this formula. The accuracy of the two models is close between 8 p.m. and 6 o'clock a.m. At other times, the accuracy of the multi-task spatial temporal network is obviously higher than that of the single task model. We think that the difference in accuracy of the two models is possibly caused by their interaction between road traffic and parking. In order to confirm this point of view, we use mutual information to measure the correlation between the road traffic and parking. Greater the mutual information value is, stronger the correlation between the variables is. It can be found that when the traffic is light, the mutual information of all the three subjects is small and very close to each other. When the traffic becomes busy, the mutual information of real traffic situation increase. The single task model obviously can't keep up with the increase of real mutual information, but our proposed model always can. Notice the accuracy gap between the two models happens to be widened at that time, so it's reasonable to infer the mutual information between road traffic and parking plays a key role in the road situation prediction. Figure 4.6 further confirms this inference. When the mutual information is small, the accuracy of the two types of model is not much different. When the mutual information increase, the accuracy of the mutual task temporal network significantly better than that of the single task model. This means that the integrated prediction model is more suitable for complex traffic environments. Finally, I will make a brief conclusion. We found the interaction between road traffic and parking. Then we built an integrated prediction model to improve the prediction accuracy. In the future, we will improve the way of spatial feature fusion according to the correlation between parking lots and roads. Thank you for listening. I will convey all your suggestions or questions to Dr. Peng Li.
Thank you, Yu Jia, for the nice presentation. You have some good results in the road traffic prediction, and you have proposed your model multi-task spatial temporal network to predict the traffic congestion. Now, I'd like to ask from the audience if they have any questions or queries regarding this presentation. I guess the audience do not have any questions. Now you may close your slides. This is our final presentation. The discussion session will be done offline, which is collaboration plans for public data refining and utilization. I'd like to ask all the attendees to say that this is the closure of our session. You may close you may leave from the room. Thank you.